A warm and a healthy good evening to all of you present at this webinar on machine learning for research. This webinar was organized by the Software Engineering Students Community of SLIIT, and thank you R Factory, a well-established award-winning software development and digital marketing company in Sri Lanka, for sponsoring our online webinar of the Technovate workshop series for the 4th time. Technovate is an online tech workshop series happening once a month where experts in each field will be sharing their knowledge and experiences with us. Machine learning is the core sub-area of artificial intelligence where engineers design and create algorithms capable of learning and making predictions. Therefore, machine learning is one of the biggest opportunities that we can think over the next decade, and its popularity increases with every passing day. So for this workshop, we have invited a well-experienced industrial professional to give you an introduction to machine learning and its applications in the real world. Therefore, we encourage all students to ask questions, and if you have any kinds of a doubt, then this is going to be a very good opportunity for you to clear them, and please use the chat box to ask questions. Also, if you are new to machine learning, and then this is going to be a very good opportunity for you to get started with machine learning. To begin, I warmly welcome Mr. Saugat Aryal, Lead Engineer, AI Practice and Research at Boolean Labs, to give us an introduction to machine learning. Over to you, Mr. Saugat Aryal.
Thank you for having me. Shall we start?
Yeah.
Right. Okay, so I hope everyone can see my screen, and so my name is Saugat, and I'm an AI engineer at a startup company called Boolean Labs. So we do different kind of AI and machine learning related projects, and also do some kind of research as well. So this is my personal email address, and if you have any questions related to your research, and if you're stuck in your research, and if you want to have any directions, so I can help you with that, but I might not help you with proper implementation or coding for the particular component, but I will certainly try my best to give you any sort of guidance and directions for your research to the best of my knowledge. So yeah, when we talk about machine learning for research, I remember a few years back, I was also, I just completed my 3rd year, and I was in the same dilemma like you all, where I wanted to do some kind of research related to machine learning. And so it was a kind of new field back then, but I think it has grown and evolved over the years now, but still there are lots of new things coming up in this field, and lots of exciting things that we can do with machine learning. So let's get started. Before starting, I'll just like to highlight that in this session, so we will not be going in deep about what is machine learning and what are the different algorithms of machine learning or deep learning. So I'll just be touching them on a fundamental level, and then I have included different resources that you can follow up and then gain more knowledge on them. But the session will be mostly focused on providing some kind of guidance on how we can use machine learning for research, and then how we can find any research ideas related to machine learning and its related fields and so on. And if you have any questions, maybe at a particular slide, so you can mention them in the chat, or we can also have a Q&A at the end of the session. So when we talk about the artificial intelligence, so there's this big bubble where everyone is talking about artificial intelligence. So what really AI means is to create some kind of a system or some kind of an agent which can mimic human behavior, or which can carry out activities like similar to human beings. So in this huge bubble of AI, we have a smaller bubble called machine learning. So this is just a part of AI. So machine learning means using some algorithms and basically some mathematical based algorithms learn to do these activities without explicitly programming them, and where they learn themselves to carry out the different activities that can be done by human beings. And deep learning is a smaller subset of this machine learning, where we use something called artificial neural networks. So those are the same attributes that we have in our human brain and how our human brain operates. And so this deep learning uses those techniques to learn and try to recreate the human activities. And deep learning, as you must have heard, it works mostly with large amount of data, but machine learning, we can use a small amount of data as well. So this is the general idea of what machine learning looks like, and what I'm going to what is the whole purpose of machine learning. So even with both the deep machine learning and deep learning, the main idea is to create some kind of intelligent system. So the only difference is, for deep learning, we'll be using a different set of techniques, and for machine learning, we use a different set of techniques to do that. And deep learning is a bit more advanced and recent version of machine learning. And machine learning is kind of a bit outdated now, and we don't use much machine learning techniques these days. But when we talk about this term machine learning, it generally means it refers to this AI and deep learning as well. So don't get confused with the word machine learning, and I might be using the term machine learning throughout this session. So machine learning in general, it means the artificial intelligence. Yes, so just a brief introduction of how machine learning and deep learning are different from each other. So in machine learning, or we call traditional machine learning, there is something we have to do using a manual or using a human intervention, or we need to extract the features from a given data set. It might be an image data set, or it might be a table with a data set. So machine learning requires that we have to extract the features of those specific data set, and then using those features, the machine learning algorithms will try to learn the patterns within the data and try to form a predictive model at the end. So machine learning involves we have to handpick the features before using them in the model. Whereas in deep learning, we just provide a bunch of data to the model, and it will automatically learn whatever the features that are needed, important features that are needed from those data set. So because of that, it requires a large amount of data to operate on. So as you can see on the image here, on the traditional machine learning approach, if you want to classify a particular image as a dog or a not dog, so what we do is we provide, we have the image of a dog, and then so we have to identify the features of the dog. So it can be what does its ear looks like, what does it eyes, does it have a tail, what does its nose looks like, hands, and so on. So we have to somehow extract those features from that image and then provide it to the machine learning model, and then where it will try to find the patterns between those features, and then at the end it will be able to classify, saying that based on these features this is a dog, and maybe based on if you provide a different set of features, it is not a dog. So that's how it works in traditional machine learning approaches. In the deep learning, so what we do, we just provide the image of the dog, and then it will automatically extract those features. So it will extract what does its ear looks like, what does its nose, hands, does it have a tail, and all those things by itself. So we don't have to do any manual extraction of features, and it will learn from those automatically extracted features, and then it will create the model at the end. So this is just a high level difference between machine learning and deep learning and how they operate. So when we talk about AI, so there are different learning algorithms that comes into the play. So learning algorithm in the sense like how these AI models learn to identify the patterns, or how either it is machine learning, or either it is deep learning, or any kind of learning AI approaches. So how do these models, or how do these algorithms actually learn from the patterns in the data set? So the different types of learning algorithms that are commonly there in the field of AI. So one algorithm is called supervised learning. So this is where we have something called a labeled data set. That means suppose in case of the classification of a dog or a cat, so we have a bunch of images of a dog, and we have to label each image saying that this image is a dog and this image is a cat. So it's called a supervised learning algorithm. So which is mostly a most common kind of algorithm that is used in machine learning and deep learning domain. And this supervised learning can be used for classification purpose. So classification in the sense where we classify into a particular category, like in case of dog or cat. So it can be any multiple number of objects. So that's what classification means. And regression means if we are trying to predict a particular value, it can be a continuous real number value. Suppose if you want to predict what will be the value of the US dollar tomorrow, and what will be the temperature tomorrow, what will be the amount of rainfall tomorrow. So those kind of problems, or those kind of domains are regression related problems. So supervised learning commonly used in classification and regression, and it requires something called a labeled data set. Then we have unsupervised learning. So just the opposite of supervised learning, so where we do not have any labeled data set. So how this algorithm works is we provide a bunch of data set to the model, and then it tries to discover some patterns within those data set. So this kind of algorithm is mostly used in clustering. So when we are trying to divide a data set into different groups, and also the recommendation algorithms, like the recommendations that you see in the YouTube and in other music platforms, and in even Amazon, and also those are kind of unsupervised learning, because we don't have a labeled data set saying that this data belongs to a particular group or category. Then we have something called semi-supervised learning. So it is kind of supervised and unsupervised. These are the most commonly used learning algorithms that are there right now. But there are some new algorithms that are there that have come up recently, and then maybe you will want to explore these learning algorithms in your research ideas, or maybe later in the future, and so on. So there is something called semi-supervised learning. So this is a combination of supervised learning and unsupervised learning methods. So meaning it contains both the labeled data sets and as well as the unlabeled data sets. So the idea of semi-supervised learning is using the labeled data set, we try to label the remaining unlabeled data set. So why do we need semi-supervised learning is if we consider real world, labeling a data set is a very difficult task, and then it takes lots of amount of time and resources. So what we do in semi-supervised learning is we provide a small data set with some labels. Then we have other data set which are not labeled. So using the labeled data set, we try to label the unlabeled data set, and then at the end, it will still be a supervised learning model. It will still create a supervised learning model. Then there is something called self-supervised learning. Again, this is a kind of new concept that has come up recently. Also the same idea is like where the humans do not have to manually label a training data set. but use unsupervised learning algorithms to generate the labels for the data set. So there is much more unlabeled data in the world than the labeled data set. And this approach uses techniques of unsupervised learning to find the patterns in the data first. And then we should have to build a better supervised model later on. So also a kind of variation of semi-supervised learning, where we don't have much label data set, but we use this unsupervised learning techniques to learn the labels itself. And then finally, we have reinforcement learning. So where we have something called agent, and then it tries to learn in an interactive environment by the trial error and then by the feedbacks from this action. So if you see any kind of robot in an environment, so this is so that robot has been trained using the reinforcement learning algorithm. So that is the most general way of teaching a robot, and so on. So yeah, these are the commonly used learning algorithms. So whenever we talk about any machine learning model or any deep learning model, it's either based on supervised learning approach, unsupervised learning approach, semi-supervised learning, self-supervised learning, or reinforcement learning. So it belongs to either of these learning categories. And yeah, so if you try to look at machine learning in terms of problems, so the other way that we can look at is the main goal of machine learning is to create some kind of model that will try to mimic human behavior, but at the same time, what that means is to have some kind of system which will make some predictions or some kind of decisions without explicitly programming it to do so. So that's the whole agenda of this whole AI or machine learning paradigm. So if we look at the problem in terms of problems that we can tackle using machine learning. So as I explained earlier, so we have something called classification-based problems. So where we use these machine learning models to predict a specific category. So it can be an image, or it can be a particular label. So any kind of set of categories. So that's what we call classification based classification based AI, or we use classification. We use machine learning to do the classification. And then we have this regression. Again, as I stated earlier, we use machine learning to predict some kind of continuous values or some kind of real values, any kind of numbers. Then we have clustering. So where we use machine learning to predict similar items, and then where we divide them into similar groups. So that's what this clustering means. Just like the recommendation systems and how this recommendation models operates. And also we have something called generation. So where we use machine learning to generate new data types. So for example, now this deep fakes, or even the filters that you see in your mobile phones, those are kind of generation. The problem that is trying to problem that the machine learning is trying to tackle is the generation and how to generate new samples from a given data sample. So these so if we these are the different ways that we can look in terms of machine learning in a different angle. So whether we are going to have some kind of we are going to solve a classification related problem where we want the model to predict a specific category, or where we want to have a model to predict a specific value, or do we want to have a model to group them together and then recommend them, or do we want to have a model where we want to generate a new samples. So based on that problem, so we can categorize this machine learning problem into one of these categories. And again, like I mentioned before, so even if you're trying to do classification, So it will be based on so whether it will be either supervised learning, unsupervised, semi-supervised, self-supervised, and so on. So classification is mostly based on, say, supervised learning. Regression, we use supervised learning, clustering unsupervised, and generation also supervised. But there are some recent trends where the research is heading to us using semi-supervised learning or self-supervised learning in order to create this kind of models. Right now, in machine learning and deep learning, so they have different types of algorithms within themselves. So for machine learning, for example, linear regression model, logistic regression, naive-Bayes, k nearest neighbors, random forest, vector machine. So these are the different models that comes under machine learning, and we can use them for both classification and for regression purposes. So the only difference is like the way this regression model operates. The mathematical functions used for regression model is a bit different than the logistic model, and then naive-Bayes and so on. So the underlying mathematical foundations of these models are different, but most of them support both regression and classification. If we have a classification problem or regression problem. So for example, a logistic regression you can use for both regression and classification. For support vector machine, you can use for both classification and regression based problems. Gradient boosting algorithms like XGBoost, and there's some other cat boost and so on. So you can also use them for both classification and regression based problems. So these are the machine learning algorithms, different most commonly used machine learning algorithms in the research and in the industry. Then we have deep learning, so different deep learning models. So all these models are based on the neurons, artificial neurons, and the neural networks. So multi-layer perceptrons. So it's just a bunch of layers of neurons connected to each other. There is something called convolution neural networks, which works mostly with image data. Then we have long short-term memory, so it works with textual data. Then we have generative adversarial networks, so this is where we can generate these different generation type of problems, like generating the filters or cartoon image of a particular face and so on. And then we have transformers. So again, this is the latest state of the art deep learning model, which is used for NLP, natural language processing, and computer vision. So I'll come back to that later. Then the Boltzmann machine and deep belief networks and so on. So in deep learning, specifically, some of these models have been designed for a specific purpose. So for example, these CNN models are designed to operate on a specific data structure or a specific pattern in the data. Similarly, long short-term memory operates in a specific data manner. So these different deep learning models, if you're using for different scenarios, so we have to select which model to use for which particular scenario, and then which one suits best in the problem that we are trying to solve. So I have added a link to website here. So here it has just explained in detail what I have just mentioned before. So we can group the algorithms by this learning style. So we have supervised learning, unsupervised learning, semi-supervised, and so on. Or we can group the algorithms by similarity. So similarity in the sense that can be regression-based algorithms, instance-based, regularization, classification, and so on, clustering-based. and so on. So you can follow this tutorial if you want to know how we can categorize or what are the different types of algorithms that are there, and then what is the model type that will be suitable for our situation or in the problem that we are trying to solve. Then we have then we call these fields different application fields of AI. So it's like in a way we can say that it's like different sensory organs of an AI system. So just like humans, so we have different sensory organs like eyes, and then we eyes we use to visualize the world. Then we use hands for touch, for sensation for touching. Then we use hands to write something. Then we have mouth to speak. So like these different sensory organs in the human beings, so there are different fields of AI that we can categorize into. So first we have computer vision, so which means how these machine learning models or AI models will derive information from the images or the videos or from any visual input. So any kind of models that is related to this visual inputs and any kind of predictive models that we're going to build comes within the field or domain of computer vision. So that's the domain called computer vision. Then next we have something called natural language processing. So this is related to the fields where the computers try to understand the text or the words the same way as the human beings can. So for example, if we have seen this translation, Google Translate, or if it's trying to predict something called sentiment analysis, where it's trying to predict whether particular text is a positive or negative or neutral some kind of sentiments, or even if in your mobile phone, so you might have seen something called autocorrect, or it will predict the next word in a particular text that you're typing. So all these things which is related to the text and the words and all the models that we try to create and all the things that we do try to do using this text and the words comes in the field of natural language processing. Then we have something called time series data. So this is where we deal with data that is associated with the time series and then make necessary predictions. So for example, in case of predicting the rain, so we can see how much rain was it yesterday and then day before that, and by looking at the history. So each data is associated with the time, and then we try to make some predictions based on the time. So that's the time series domain problems that we're dealing with. Then we have something called the expert system. So this is where the machine will try to provide kind of explanation or advice to the users. So maybe chatbots can come under expert systems. So where we can converse, or then maybe can analyze what you are trying to say, and then it can give any recommendations or help with certain activities. So those kind of models comes under these expert systems. Then we have something called speech recognition. So this is where we try to build models related to understanding the words. So when we speak something, so for example, to Siri or Alexa, and then they try to understand what we say, and then give the answer, and so on. So the models that deals with the speech data and all the things that we can do within using the speech data comes under this speech recognition domain. Or we can say we are trying to solve something in the domain of speech recognition, or our problem is related to speech recognition. And finally, robotics. So if we are trying to build some kind of agent or a robot to perform specific tasks, so it's kind of robotics domain of AI. So it involves both the hardware and the software. So this is these are the most commonly used fields of AI, and maybe so one of the problem or the research problem that you guys will be solving will fall into one of these categories. So either it will be a computer vision problem, or a natural language processing problem, or time series, or a speech recognition, and so on. So there can be situations where you can have these multiple fields within one research project. So maybe in one bigger research project, one component can be to computer vision, one component can be related to natural language processing, other component can be related to time series, other can be speech recognition, someone can have robotics, and so on. But on a high level, so it will be into one of those fields. So this is just to if you try to divide into these categories, it will be easier to find related resources, or these are the most commonly used technologies. So we can use these terms to define what we're trying to do, and also maybe look for solutions for our problems. Now, so those were just a high-level idea of what AI is, and then what are the different branches of AI, and then different algorithms and models. So I'll be not going in detail about these models, because the objective of this session is not to explain about these models and then how it works, but just to give I just wanted to give a high-level idea on so that you have an idea what are the different things are there, and then what are the common terminologies, and what are the different algorithms, and so on. So this is the main objective of this session is, so even though we say machine learning for research, it's actually machine learning for CDAP module, for specifically 4th year research project. I just want to lay out some truths before you guys starting reading the research. Some of you might have already found a research idea, or some of you might be on the verge of finding research idea. So these are the things that I realized, or maybe during our time, we went through some of these facts, and then later on we realized that these are the important things that needs to be remembered by everyone. So first thing is, do not have a very high expectations such that you will be building a very super intelligent robot or a very complicated AI system like metrics and so on. So if you have something, because since machine learning is it's a very trending term, so some of you might have thought that we're building a very general AI or a very complex system. So that is not going to happen, at least in this CDAP project, because it is not very realistic and also practical due to different, especially because of the time and the resources. So you will have around 6 to 8 months to complete the whole project. So you will have to find something very reasonable to do. And I think there is also something called project charter, so where you will be proposing your ideas to some kind of panel, and then they will be accepting the project. So it's better if you don't come up with a very complicated project, because it will not, virtually it is not possible to do within CDAP. So this is not to demotivate you saying that it cannot be done, but with the given time and resources and the level of expertise and knowledge that we all have, it is not possible to do in the 4th year, but you can continue that research after 4th year, and then you can start your entrepreneurship journey, or maybe you can start your academic career continuing that research. And lots of my friends have also done so, where they take their final year research and then they try to make it into a company, or they try to make a bigger product out of it. And machine learning is just a small component in the overall research. So so whatever the research ideas that you will be proposing, so machine learning will just be a very small tiny part to that overall system, or to that overall project. So there will be lots of other things that we'll have to do, like documentation, and then reading lots of research papers, and then lots of other things. But training the model and then creating a model and making predictions is just one component, or a small component of the overall research idea. And also one thing that I would like to suggest is try to have some kind of idea which is as simple as possible, and then but at the same time it has some high impact and some high value. So I know it's not very easy to find ideas, and then it's not easier like it's said, but try to find some ideas. So I have listed down some tips and some techniques of where you can use to find some research ideas without making it a very complicated one. So ideas should be as simple as possible, but it should have high value and impact. So maybe it can high value, it can impact, it might have a high social impact value, or it can solve a very small problem that maybe a small group of community is facing. So even that kind of research is very valuable, instead of making a very complicated research. And yes, building backend and front end will not be a research component. So that will be as a part of overall idea, overall project. So everyone will have to work together to create the backend, the front end. So the components, different research components will be maybe building AI models, or for some of them it might not be related to machine learning, and maybe something other. But at the end, it should be an overall system, integrated system with different research components, where we have an interface to use that system. Yeah, now the main problem or the main question is now how to find the ideas for the SLIIT project. So some of you might have already found, or some of you might be looking for ideas. So there are basically two ways that we can look to find a research idea. So one is something called problem-based research, or we can say it as application-based research. So in this approach, so what we try to do is we try to find out some kind of problems that is there in our existing scenario. So maybe in our home, in our locality, and anywhere. It can be a local problem, or it can be a global problem. And then we use these machine learning algorithms or models, and then maybe fine tune them or adjust them to solve those kind of problems. So that is this problem-based research. So the idea is to find the problem, and then based on the problem, we find out, okay, what are the AI models, or first of all, do we really need machine learning? And if we need, then so whether it is a classification-based problem, or whether it is a regression-based, or time series-based, or so on. And based on that, so we have to decide, do we have to use machine learning, or do we have to use deep learning? And if we have to use deep learning, so if it's something related to computer vision, so what are the different models that we can use for computer vision? So you'll have to break it down into different components, and then different pieces before starting the research, and then have a clear idea about what the problem is. So that is one way of finding a research idea. So where we find a particular problem, and then maybe use some kind of new data sets. So there can be one problem, some same research idea which has been implemented in US or Europe, but they have done it with their data set. But if you try to solve same problem with the new data set that you can generate in the local context. So that can be also a research component, but you'll have to do some fine tuning here and there in the models to adjust it. But I believe, yeah, it might be acceptable if you're trying to solve a problem in the local level. And then there is something called theoretical based research ideas. So this is kind of complicated one. So where we try to develop some new learning algorithms, or we try to fine tune a new existing learning algorithms. So for example, if we have this linear regression model, so maybe we try to create a new model, create a new machine learning model for regression, and we have to justify why we created that model, and then what are the advantages of that model over to the other existing models. So these theoretical based research ideas are a bit less common, and it's very hard to tackle in the CDAP project, at least. So most of the project ideas, even the past project ideas that you may see, is mostly this problem based or application based research ideas. And the expectation of the CDAP is you need to have 4 different research components. So each of these research component will have its own independent research, and then you'll have to finally integrate this together to create a final application. So it can be a mobile application, or it can be a web application at the end. So that's the expectations of the CDAP project. Now, so how to find research ideas? So I might not be able to provide you with some concrete ideas for your research, but I have listed down some techniques which you can use to find research ideas. So if you're trying to find ideas based on the problems, so we can find problems in a specific community, or maybe in the city that we are living, or maybe in the neighborhood, or even in Sri Lanka. So it does not have to be a global problem. Like I mentioned, it's better if it's a global problem that you're trying to solve and that you're trying to improve. But even if it's a local problem, similar local problem that you're trying to solve with some few enhancements, so it is also acceptable. And in fact, that will have more value when you are applying for some of the competitions and all. So yeah, you can find problems related to your community and society. And so one of the so now how to find the problem. So so one way is you can talk with non-technical or the normal people who are not that much familiar with technology. So there can be people from different backgrounds. So you can talk to them and then see what are the problems that they are facing, and whether it can be solved using technology. And if yes, maybe if whether AI can play a part in solving that particular problem. So since all of you are from the technical background, and you are studying these models and algorithms, so it might be difficult for you to find the problem. So one way is to talk with the normal people from different backgrounds. So it can be anyone, like maybe a shopkeeper, or maybe electrician, or maybe a plumber, or maybe any normal people, tuk-tuk driver, or yeah, any kind of people. And then so where we first identify the problems that we can solve, then based on that problem you can try to formulate any research idea that you can use to solve that project. And apart from that, so you can also explore on your old daily schedule. So from the time you wake up in the morning to the time you go to the bed at night, so everyone gets involved in different activities. So we go here and there, do lots of things. So there might be some things that might be that you all might feel that we can improve this particular activity, or there is a problem with this. So you can look into that. You can do a bit of introspection and then see if there is a problem, if there is actual problem, and identify a problem and try to list down the problems and then see if you can make it as a research project or a research idea. And other thing is like, many of you might have different hobbies and passions. So so all these research ideas, it doesn't have to be specific to this software engineering domain. So it can be maybe integrated with different fields, other domains. Like, so if someone is interested in singing, or maybe in dancing, or maybe in interest in entertainment industry, if someone is interested in drawing, and lots of other things. So maybe try to explore those areas and then see if there is a problem that lies, and if it can be solved using technology, and if AI can play a role in that, in those fields. So the overall idea is just to find the problems. So it's not easy to find, because most of us, we are all maybe looking in a one directional way. So the best approach will be to talk to other people and then get their idea, and or maybe read 3 different articles in the internet, and then listen to other people's ideas, or listen to other people's problems, maybe podcasts and all, so different kind of things. So that is where you need to identify the problem and then build upon that problem. So these are some of the research problems that can be done. Maybe most of these might have already been. Most of the research in these things are already there, but you can definitely look into that and then see if you can improve upon these researches. So one of the research idea can be something called this sign language detection and translation for deaf people. So for people, the sign language, as I heard, is very different from country to country. So the sign language used in Sri Lanka might be very different than the sign language in Australia or USA or Europe, somewhere. So just see if there is any research done in this area, and if not, you can look in to this area as well. So sign language detection is where people, they do some gestures with their hand, and then it will kind of do automatic translation to the normal people. Because in order for us to understand the language, we have to learn the sign language. But for normal people, what can be done is using this AI. So this is where this computer vision comes into the play. So where we look at the gestures of these people, and then identify what they are trying to say. So it can be a system like that. So one of the major challenges can be to find the data set now, especially if we are dealing with trying to build AI machine learning problems. So I'm not exactly sure if there is any kind of sign language data set in the Sri Lankan context, but yeah, this is where if you are interested in this kind of idea, so we'll have to maybe connect to some authorities or government authorities and check with them, or maybe if they are interested, so you can collaborate with them, and then if they can provide the data set, so then you can work upon that. So that will be interesting idea to work on. And even if the idea is there, so you can think of any improvements that can be done into this problem. And similarly, so for blind people now, if they're traveling in a bus or something, so they since they can't see, so they don't know the denomination of the note, whether it is 1,000 rupees note, or whether it is a 500, or whether it is 100 rupees note. So we can have a computer vision system where they just take a picture of that image and of that note, and then maybe the system will say that it is 100 rupees note. So something like this. So this is just one idea. I think there are systems like this, but just to give you an idea on different areas that research areas that you can look into. Similarly, for other disabled people, like people who are going through hearing loss, so there we can build some models where we do some kind of speech recognition, or where we also have some kind of natural language processing. So combining those two fields together to help these people and to make their lives a bit better. And this speech translations have been are very common, and even Google and other lots of companies are doing. But when it comes to the local Sinhala language, it might not be that accurate. So you might want to look into the Sinhala Tamil doing this translation and so on. And one other thing can be so traffic in Colombo it's going to be it's a major problem now, and then maybe a couple of years later it is going to be a major problem to the government and to the authorities. So maybe you can find develop a system to find optimal traffic routes or some other kind of systems within this traffic domain, so we can optimize the traffics and so on. And so one other area that you can look into is this disaster management. So like currently there was lots of floods and landslides in different areas. So so you can go and talk to the people around that, or see, or maybe you can study on your own, do some own research, and then see if AI can help to do that. And we're predicting these floods and landslides also is one research idea, but maybe how to organizing the resources or providing them with facilities and so on. So those also can be one kind of research idea that you can look into. And so due to COVID, so lots of problems have arrived, and then it was not a very good time for the past couple of years. But at the same time, if we look at the positive side, so we can also look at the different opportunities that have come up to COVID. So like this long distance learning, Zoom and other platforms have been very popular, and delivery of goods and goods and so on. So maybe you can look into that areas as well, and then see the problems that occurred due to COVID, and whether it can be solved using AI tools, using technology. And so this is one of the research idea that one of my friend did during our time. So what their idea was predicting the movement of animals in wildlife national parks. So they did for Wilpattu National Park. So the idea is when we go for a safari ride or to a national park, so we don't know exactly where the animals will be, and then we might miss sometimes if you want to see a particular animal. So by analyzing the past behavior and the movements of the animals, so we can maybe it can be used for the wildlife authorities, and then they can use that to say that maybe this animal can be in this particular region at this time. So the idea is to predict the movements, and then so that the tourism industry can have a bigger impact. So this can be done for animals or even for birds or different kind of other things. So just one dimension, and then if you feel interested, so you can further explore and then see what are the existing things that are there in this area, and what are the things that you can improve on, and maybe you can find your own search idea. Then this automatic question answer generation, so that is most common for English-based text. So maybe we can see if, how common it is, or what is the state of the art for Sinhalese or for Tamil text if you want to generate the automatic question answer. So that can be another research area that you can look into. And also the sentiment analysis. So again, it's very common for English languages. but Signal is not sure if since it's a low resource language. There can be further improvements that you can do with the new models and the technologies that have come up recently. So in some of the situations, one of the challenges can be finding the data set. But if somehow you can manage to find a data set, so this will be more valuable research for in a local environment, or for your country, or for your community. But at the same time, yes, you can also go for any global problems and try to solve any of those problems, or try to improve on those problems. So other place to find research ideas is so in our time, I think even still there is something called cdap.slit.lk, where you can look at the previous research works done, and then you can talk to maybe the people who did those research works, and if it is of interest to you. And also, if you feel that a particular research is interested and you want to further improve on, so you can also talk to the supervisor who supervised that project. So my suggestion would be not to go blindly to a supervisor, but you need to at least have some idea, set of possible ideas with you before you talk to supervisor, because that will make things a bit more easier. But sometimes a supervisor can also have an idea with them, and then so if that's the case, so you can talk to him and then see if the idea is suitable for you and if you're interested. And other thing that I wanted to highlight is you'll have to find an idea that will be that sounds interesting for you, and then that you will be interested to work on for at least 4 or 5 months, because it's not a 1 or 2 month project, and then you will have to invest a lot of time and resources. So if you're doing something that does not interest you, and if you feel bored in the middle, so everything will scramble. So try to find something that is of interest to you, and also so that which you can stick to until the end of the project, so you can complete the overall project and then submit it. Then so other place is obviously where you can go and look for research papers in the internet. So there are websites like this Archives Sanity. Let me Archives Sanity. So where so where you can see, okay, what are the recent papers are there, and then if you want to look for any paper like object detection, so it will show the most relevant paper to that problem or to that application, and then you can read that paper, more on that paper if you're interested. So this is one place where you can see research papers. So this is mostly papers related to computer vision and artificial intelligence and so on. Other good place is obviously IEEE, so where you can go and explore the papers in IEEE and find any research ideas based on the papers. Then Google Scholar is a very common place. So here, so you can search for a problem like Bitcoin forecasting. So here, if you are searching, you can search sort by this date attribute here on the left side. So after searching, so it will show the most recent research papers related to that. So this is 17 days ago, this is 23 days ago, and so on. And you can now go and study these papers and then see what are the research ideas that you can get. And then so Science Direct is another one. And then there is a third-party engine, which is not ethical to use, but since we all are students, so if for any research paper, what we can do is, so for example, if we have a research paper like this from IEEE, and it is not accessible for us, so in this case, okay, so I think through SLIIT you can access these websites, but maybe in some cases, if we cannot access a particular research paper, for example, if we go to Science Direct and then okay, maybe this paper. So since we cannot view this paper, so what we can do is maybe we can just copy the title, or then we can copy there's something called DOI to this Sci-Hub, and then it will get the paper for us, so we can read. So there are different versions of Sci-Hub that you can get. I guess you have to find the one that works. Yeah, maybe it might not be working right now, but okay, it says it has not been included. Yeah, so but most of the articles you can which are not accessible through the academic search engines, you can use this site hub to get the ideas. And then there is also a website called LibGenesis. So this is where you can find books related to machine learning or any kind of books that you want to learn. So here now you can see lots of different books, and then you can see select one of the mirrors and then select the books. So this contains almost all the books that is there in the Google, I guess. So you can also use this if you want to read a particular book to get some more research idea. And other place where you can look for ideas is now Stanford University. They provide these online pages. So they have this page module for machine learning, and then where they have something called projects at the top. So you can see, so they have projects from 2004 to 2021. So if you click on a particular year, so you can see what are the projects that the undergraduates have done in the Stanford University for this year. So you can go through that project, and then if you want to read, suppose if you are interested in traffic flow prediction in urban areas, so you can get the report, or you can see the research paper written by them, and then you can get some more idea about that particular research problem. And by looking at the problem, reading through the paper, so most of these papers provide the code as well. They should provide the code as in the GitHub code as well, and yeah, since this has not provided, yeah, but you can read all the papers of the different researchers, and then if anything is similar to your research area, since Stanford, and then the research that they will be doing will be a bit state of the art and a bit more advanced, so you can follow their research papers and then see what they're trying to do, and maybe try to do kind of similar things, but with some few enhancements, so that can be also acceptable. So they have one page for this machine learning, and then And then they have another page for deep learning. So this is also there's something called projects at the top, and then you can see in the past projects. So starting from 2018, 2021. So if you want to see when this project, so you can see the project and you can read the paper of that. So these are all undergraduate final year research projects of Stanford University. So you can look through them and then try to do something similar or maybe fine tune it and so on. And so I found this GitHub repository which shows how machine learning or data science applications can be used in the industry. So they have different industries like food, accounting, agriculture. So if you go to agriculture, so how maybe we can use AI to predict the price, or we can use AI to look at crop yields. So these are again projects, individual projects. So you can go through them, and then if you are interested in a specific domain or a specific field, so you can try to use that as a basis, or try to improve on it, or try to fine tune it, and then make up your own research idea. And one thing that I would like to say is, so whatever research idea that you will be that you will have at the end, it will be very, it will not be a very new idea or novel idea. It is very difficult to find a novel idea, so that is also fine, because it's very difficult to find some new ideas. So even the ideas, some past ideas, and then with some improvements, will be also is also acceptable. And if we can include further more features to the past ideas, so that's how this all research works continue in the academics domain as well. So yeah, so these are some places where you can find some research ideas and some papers. And other thing is, like, so you will have to couple the research project with at least one of the domains. So it can be AI in educational domain, or AI in health domain, or AI in finance, or agriculture, or whatever. So there are different domains that you can look into. So if you're interested in doing something in AI in agriculture, so you can maybe look for ideas into that. If you're doing in for if you want to do integrate IoT and sensors in your research, so you can also look at that domain, and also in the healthcare. So for each domain, so you can look at the problems or recent problems that is there, and then try to see if we can improve or further build upon it. And it's always better if the AI is it's also better if we can find a specific sustainable goal for your research idea. Suppose maybe if it solves the hunger problem, or if it solves the poverty, or if it does helps in eliminating gender equality or gender discrimination and those kind of things, or helps in the well-being of people. So if the research idea is in one of these domains, so that will be extra point for you if you're trying to apply for some other competitions and all. But again, it's not a mandatory thing, and then it all depends upon the problem that you have identified, and the interest in a particular field. So now, after you have identified the problem and the research idea that you're going to face, so one thing that you will have to do is read lots of research papers, and then so the main idea is to see what are the existing things or existing projects, similar projects that are there in that is common with the research idea that you have selected. So you'll have to read lots of papers, and then you'll have to find the limitations of those papers. And then based on those limitations, so you'll have to improve upon that. And also when you're writing the research paper at the end, you will have to do some kind of literature review. So where you'll have to list down what are the papers that you have studied, and then what are the things that you have, what are the things are there in those research papers. So this is a very short article is on how to read a research paper. So there is an approach called three pass approach. So first, in the first pass, what you do is you just do a quick scan or on high level scan of the paper, and then we try to understand that is this the paper that you actually need, or is this the paper related to your research or not. So that's the first pass. Then you do if it is the first pass, then what in the second pass, what you have to do is you can have to read the paper a bit more details, but you can ignore mathematical stuffs and other little proofs. So what you can do is you can look at the figures and diagrams and try to understand the paper a bit more in detail, and then see if it is relevant to you. And if after going through the second pass you feel that this paper is very much relevant to your research idea, then what you'll have to do is do a third pass. That means maybe read the paper again, and then maybe in this case try to fully understand the paper. So yeah, in the research paper you will have to do something called literature survey. So this is where you will have to read lots of research papers and try to find what are the things the previous researchers has done, and then what are the limitations of those researchers. So this is where you can apply this 3-pass technique, or this is just a standard technique and it's not a mandatory thing. So you can use, you can read the papers through your own way of reading as well, as long as you get the overall idea of the paper. And while doing a literature survey, so there are papers called the survey papers. So if I go to Google Scholar, so if I want to do a sentiment analysis project, so if we search for a survey paper, and then if we see any survey paper related to our note, suppose maybe in this case, so for example, like if you're doing some kind of financial prediction system or research idea, so if you search for a survey paper or maybe a literature review paper, and if you find a paper like this, so you can directly go and read this paper. So what this survey paper does is it will automatically have the summarized version of all the research papers related to this domain. So you will not have to read them in detail. So you can just read this paper, and then you get the overall idea of that domain. So in some cases, there might be survey papers available. In some cases it might not be available. So if it's available, it's good for you. Otherwise you will have to read papers, lots of research papers, and then other research papers that you can find. Suppose in this case, if you read this research paper, and then if you want to find more related papers, so what you can do is there's something called references at the end of each research paper. So you can go and look at the references, the reference papers of that research paper. So that's how you can find more research papers related to the same problem domain. So that's for reading and then finding research papers. And I got one question in the chat saying how proficient should one be in mathematics to engage in research involving machine learning or deep learning? Yes, so if you are doing some kind of theoretical or more algorithm-based machine learning or deep learning research, mathematics and statistics, calculus is a very obvious, is a very must thing, and that you need to have, because without the knowledge of that, you cannot develop these new algorithms or new models. But in case of CDAP research, at least for the final year, you don't need to have that much knowledge in mathematics, because there are different tools available and frameworks available which you can use to generate the models. So you won't have to go into a mathematical detail that much. But if you are interested, and if you're researching in a research idea, if there needs to be any kind of mathematical functions or mathematical things, then yes, it's better to have mathematical derivations as well, but it's not a mandatory thing, at least for the CDAP. So even with a normal application based, where you just apply machine learning or deep learning using one of the tools or frameworks to the problems, you can get good grades. So you don't need to have knowledge of mathematics at this point. Any questions so far? If you have any questions so far, please put it in the chat box. And if something is not clear as well, if not, then we can move ahead. Yeah, so I don't see any questions right now. Yeah, okay. So maybe we can take questions at the end as well. Right. So now, after you have identified the research problem and the research idea, and then you went through the research papers and all. So now, how to do the research? So step one, to find the research idea by exploring through problems or going through by reading the papers and so on. Then second step, do literature review, and then you will have to find something called this research gap. So this is where you go through the research papers and then identify what are the limitations of that research paper and what that research paper is lacking. So you will have to find the research gap into the problem that you're trying to face. After you do the literature review and identify the research gaps, then you will have to identify the research components. So it can be 4 components or 5. So identify the different research components. So one component can be related to computer vision. So you have to be a bit more specific. So maybe one component will be object detection of animals, something like that, or classifying the sound of birds. So that can be one research component, and so on. So you'll have to identify the research components. Then you'll have to look into your research components and then see if you need to find some data sets. So if it is machine learning or AI based research components, so you will have to find the data sets to that and see if there are any data sets available to that, or if you need to maybe create your own data set. And after that, you have to implement, so using any frameworks or using tools, so you can implement that research component. And one of the important thing is we'll have to do evaluation, and then you have to compare the results of your methods with the previous researches. And then, so these are called baseline approaches. So baseline in the sense you have to first identify what are the common used approaches and what are their accuracies. And so you'll have to do evaluation and comparison, and then see how your method or how your research component is better. And you have to show that your results and the things that you have done is better than the previous ones. So the evaluation at the end should always contain your results. So in most of the cases, it's always better to show, if you have done a research where you can show that your results are better than the previous ones. So in some cases, you can also just say that it has you didn't get much good results, so that is also a research, but you will have to justify that why you didn't get good results using this approach. So this is where this evaluation and comparison you'll have to do in your research. You'll have to probably write in your documentation later on. And finally, you can write research paper, and then you can do some publications after you have done all the research and all. Right now, so these are some websites where you can go and find some data sets. So the common one is Global Dataset Research, where you can find if you want to find any data sets related to COVID. So you can see, okay, what are the different, so this is a CSV data set, and then so on. So what is the description? So what are the different attributes in the data set, and so on. So Google Dataset Search, Kaggle, another place to find data sets. And then for Sri Lanka, there is something called open data.gov.lk. So this is where you can find some local data sets. So for example, if you want to find any data sets related to agriculture, then you can go to that field, and then you can see, okay, crop forecast data set, or cereal production statistics data set, and then we have tags as well, fertilizer, cash grant, something kind of data sets, and so on. So you can find some local data sets through here. So, and then other places are this Data Hub, and Hugging Face is another very popular website where you can find data sets related to natural language processing. Then other place is this Papers with Codes. It's also it's a very comprehensive website where you can find the data sets, and at the same time you can what you can do is you can find the papers and then see if there is any code for that particular paper. So suppose if this is the paper, and then if you want to see the implementation of this paper, so you can go and see the code of that paper and then see how they have implemented. So maybe you can use the same code of them and then try to improve the code as well. So this is where you can see the papers and their codes if it is available. And if you want to search some, there is a section called State of the Art. So if you want to see, okay, now what is the state of the art? So state of the art means like what is the latest research. So if you want to see, okay, what is the latest thing in computer vision in image classification. So if you click on image classification, so this is the paper. And this is another paper with the state of the art. So this is the most state of the art paper. This is another state of the art, and then so on. So you can see papers and then what is trending in that particular application, and then you can see if the code is available as well. So this is also good place to explore for your papers and for the codes if you want to look for any coding implementations. And then Reddit. So there is a Reddit platform, so where they have listed some data sets as well. So yeah, that was mostly about finding the research idea, and then how to at least start with the research idea, reading papers, finding papers, and then finding data sets and so on. So I didn't include the part to since the session was not okay. I have a question. Can you send this PowerPoint slide? Yes, so I'll be sharing this. So I think your system, Rishad or anyone can share the slides as well. When doing our research, if we get a result with a lower accuracy than the existing research, by justifying the results, can we get the maximum research marks for the project? Yes, so the ideal situation will be if you do a research where your results are better than the previous results. So that is so there are no questions in that. But now in cases where you do a research and then at the end of the research, if your results are not better than the previous research, so you can also get some marks, but then you will have to talk with the supervisor, or at least try to see why you didn't get better results. So you will have to have a proper justification of or proper reasoning, saying that because of these reasons, I didn't get good results. But at the end, that is also a research, because you are saying that using that approach or using that method, you will not be getting good results. So that can be a reference to some other people who are doing that research, or maybe later on you can use that paper and saying that since that approach didn't work out, you can later on use some other methods to do the research. So yes, it is possible if your research, it didn't get good results, but you need to have a proper justification. And I think it depends on the problem also that you're trying to solve. So if it is a domain where it is very hard to get good results, then it can be acceptable, but it's always better to have the results better than the previous ones. Yeah, so these are some of the resources that I have listed down, so you can go through them. So if you want to learn more about deep learning, and then maybe starting from the concepts to some advanced deep learning, so different resources are there. So some resources are from MIT, and then there is this Coursera specialization. So this is mostly common among the people who are starting with deep learning. So if you go to deep learning specialization courses, so they have different courses with different things. So this is one of the go-to course for deep learning. Then there is a GitHub repo called Awesome Deep Learning, where you can find different books, links to the books, courses, video lectures, papers of the deep learning. If you want to see any tutorials, and then if you want to follow any people who are doing deep learning researches, any websites and data sets, and then yeah, maybe conferences, and then frameworks, so different kind of things. So you can do this. Right, so there are other resources that you can explore, and then get to know more about deep learning and then its related concepts. So if in your research project, if you're going to use deep learning, and if you want to know more about concepts, so you can go to them, or you can search more in the internet and the Google as well. And then there are some other resources. So there is in AI. So there are very top-rated conferences. There are multiple top-rated conferences. So one of the top-rated conferences is NIPS. So this is where the highest or top-rated machine learning papers are published. So this is so if you want to see so NIPS 2021. So if you want to see what are the papers on this particular conference, so you can go in. Okay, so this is on December. So we can go for 2020 NIPS. So here, if you want to look at the, the videos, so videos of the papers of the conferences. So they have this video section, and then so they have different presentations about different papers in that conference. So you can also go through that paper. So yeah, so this is one place where you find most recent state-of-the-art machine learning research. So these will be mostly very theoretical, and also it might be difficult for you to understand. But yeah, if you are interested, you can go and explore this research. And then there's another conference called ICML. So again, it is a very top-rated conference. So where you can find where you can find papers related to machine learning in this. So these are very theoretical and then very advanced papers. So it might not be relevant for you, but like if you wanted to just get some idea or look at the things that are going on, so you can go through them as well. Then there is this videolectures.net. So this is where these conferences, videos, and maybe some lecture videos by different universities are published. So you can go and search about that, and you can listen to this videos. And similarly, slides live. So again, this is another place where you can go and look at the presentations of the research, or look at particular research ideas and so on. Right. And then you can export these other resources as well. Yeah, and then now when it comes to using libraries or tools or frameworks, so when you're building a machine learning or deep learning models, so you can use these existing tools and techniques using existing frameworks to build the models. So you don't have to build anything from scratch. So you can use these frameworks. So like Keras, PyTorch, or there's something called PyTorch Lightning, which is the lighter version of PyTorch. And then there's another framework called Fast.ai, which is based on PyTorch. So it doesn't matter like which framework we choose. Each of these have their own limitations and their own advantages, but at least for the research at this CDAP level, you can go with either one of these. And then, so I have included some other tools here that you can use to go and explore around. So I think I'm getting a bit late behind with time, so I'll just quickly go around with this. So now when we talk about this NLP, natural language state-of-the-art models, so there is something called transformers, so which are the latest models for natural language processing. And if you want to learn more about transformers, so you can follow these links. So if you want to do any kind of like text related things, so you will be using transformers. And transformers are also now being used in computer vision. So they are also the latest state of the art in the computer vision. So previously it was convolutional neural networks, but maybe in your research project, so you can explore transformers in your computer vision, and then it can be a novel component. So this is something that you can read about transformers in computer vision. Then if you want to know more about natural language processing and its data sets and other things, so I have included some resources for NLP specific domain. So you can go and explore these things. So you can find the problem, NLP problem, and then you can see if it contains one of these. And also if you want to know more about computer vision and then maybe advanced computer vision, so you can follow these. So some of these might be a bit advanced and you might not need all of them, but yeah, if it's your interest and if there is something that you're trying to do, you can go with these resources and then try to get some knowledge on them. I think there's a question. Then now when it comes to deep learning, so it mostly requires large resources, so mostly GPU or TPUs, or even high-end CPUs. So it might be difficult for you to train any models on your local machine if you have a not very advanced machine. So you can use this free cloud platforms like Google Colab, or even Kaggle has free GPU platform. There's a website called Gradient. So this is where you can, so if you look at Google Colab research, so this is where you can maybe if you're trying to create a new model, so what you can do, you can create a new notebook, and then so here you can upload any dataset files that you have, and you can select the runtime from here. So if you go to runtime and then change runtime type. So there is something called GPU and TPU. So GPU will be enough. So you can select the GPU and save it. So whenever you run this notebook, it will be running the GPU in the cloud. So it will not take your resources. So Kaggle is there, and then there's something called Gradient. So that also provides free GPU. And now after you have completed the research, towards the end, there are local competitions called NBQSA and ESOBIMANI, and also I think there are IEEE local competitions, so where you present the research idea or research project that you have done. I'm not sure about NBQSA. I think the SLIIT will select a few projects and then send them. But for ESOBIMANI, I think everyone can apply for this competition, and then you will be awarded with certificates and some trophies if your idea is good. So for these competitions, yeah, it's always better to have, or even for anything, better to have research with some social impact, or which solves a very critical problem or very even a small problem. Then it will have more value, and then you might have better chances of winning. And also, if your research paper is selected in one of the competitions, so there is a higher chance that you will get at least an A- or an A. So it's kind of like they don't say that explicitly, but with the previous experiences, so there is that feeling that if it has been selected to one of the competitions, then we will get better marks. Since it's 16 credits module, and then it will be 50% to your whole GPA, so I hope that everyone will try their best to do some good research which will solve some existing problems and have a good impact. So that's the whole idea of the CDAP module. And you can also publish, you need to at least publish one research paper. I think that's also a requirement for the CDAP module. If you want to get good grades, at least you have to publish one paper. And it's also good, like if you want to pursue your higher academics career, so you having a published paper is good. So you can publish paper in different conferences or journals, but since now it depends on the kind of research idea that you have done, so you don't have to go for this higher. Your papers will not be accepted in conferences like this, but there are other very good conferences as well where you can apply if you feel that your research idea is good. So one of the other advantages of this publishing in conferences is before the pre-COVID era, like if you publish to a conference, so you get to travel to a particular country and then go and publish your research. Do a presentation of the research. So that's also a good experience. But with this COVID, I think the past few years, it has been mostly virtual. But if it happens maybe physical, so it will be a good experience for you as well if you can go and publish to an international conference. And so you have to look at something called H-index. I think it will also mention this in the sometime later in the year that you have to publish in higher H-index conference or journal. So these were some of the research ideas like I found from the Stanford one was a bit interesting. So you can go and explore these ideas and then see if it is relevant or it seems interesting for you. And so these are some of the recent trends in AI. So something called multimodal learning. That means instead of using information from only text or image or a speech, so in multimodal we combine inputs from different modalities, or they call different inputs. So we can create a model like that. So that is also very trending these days. Then there is something called bias and fairness in AI. So like AI models have been been a bit biased towards certain ethnic groups, communities. So you can also look into this research field if you're interested. Explainable AI, again, another emerging research field, because deep learning machine learning models, they are like kind of black box. They're assumed to be like a black box, but with this, if you there are certain techniques or methods in the explainable AI where we try to explain what are the predictions made by the model, and then we say, okay, why the model made this kind of predictions. So that is also a very interesting research idea. Then federated learning. So this is where we kind of decentralized machine learning. So instead of training into one machine, the data set will be divided over different machines, and then it will be trained, and maintaining the privacy. So you can look further into that. Then graph neural networks are again a new type of neural networks which you can explore and then see. Then again, something called adversarial attacks. So normally these machine learning or deep learning models, they can be fooled. Like, if you provide an image of a dog, it will predict a dog, but if you add some random signal to that image, it might predict something else. So that is called adversarial attacks to the machine learning. So you can also look into some research areas where on how to make these models more robust and then more protected from these adversarial attacks. And self-supervised learning, like I explained in the beginning, where we build the models with less data, with less labeled data, another emerging field. And then there is a website here which lists down some of the trends in this research in the AI domain. So finally, to conclude, try to find idea. Again, it's not simple, but yeah, it's not easy to find the idea, but try to find it as simple as possible, and then at the same time such that it has some impact. So it doesn't have to be a impact to a larger community, even to a smaller community, it brings some impact, then it has more value. And then do a proper literature review, so that at the end of the research project, you will have like at least an idea of all the things in that research, on things that you have done, and whatever the things that are there in that research domain. So you need to have an idea on that. And you will have to have an integrated system at the end. And then other important point is you have to start as soon as possible. I think that I think some of the things have already been started, but if you can start as soon as possible, then you can finish earlier at the end, and then it will be easier for you to get involved in some other things. And also keep in constant touch with the supervisor or the supervisor, and at least once a week, or maybe according to the availability. So where you can discuss your updates, or maybe some of the issues that you are facing. So the supervisor can help you on how to tackle those issues, or maybe where to solve those issues. So always keep in touch with the supervisor and co-supervisor. And also keep exploring about competitions. I think there are different competitions that are available where you can apply your research project ideas, and then where you can go to competitions and then win different things. Yes, so that concludes the overall session for today. And yeah, I'm happy to answer if you have any questions. Okay, so I can see some questions here. If we want to do a research related to brain signal processing, where can we get good resources? So yeah, maybe you can first simply Google brain signal, go to Google Scholar, or maybe Archive Sanity and those kind of things, and then you will find papers related to that. Or also a good place is GitHub. So maybe if you search in GitHub brain signal projects, so you will find lots of projects to that. So there is no specific place for this brain signal processing, but yeah, you'll have to explore and then see. But you can explore these resources that I mentioned, where you can go and see if there are similar research papers, or if you can get any resources to that domain. Is there a concept called deep dreaming? I have not, I think I have not heard of something called, but yeah, maybe at one instance, but I'm not sure whether there might be a concept called deep dreaming. And yes, again, so maybe it might be a very complicated thing, and then you might be thinking about doing these complicated things, but please make sure that you choose a project that you can finish in time, and then it is not very complicated, and then which you can do using the resources. Because if you're going with this brain signal and then this deep learning and deep dreaming or very complicated projects, so you will need lots of resources, maybe even the hardware resources. You might have to use some external devices to get the data and so on. So yeah, if you are jumping into that, please make sure if you can that you have the resources ready before jumping into these things. Then yeah, so again, present PowerPoint slide. Yes, I'll be sharing this slide, so you can go and look at these materials. Right. Yeah, and if anyone has any questions related to the research, so please don't send an email asking for any specific implementations. But if you want to look for a specific directions to a research, so you can email me, and then I'll try my best to help you as much as I can. Right. Anything else? Any more questions or any clarifications? And I hope this session was helpful to you to some extent, and then you can start looking into your project. At least it gave you some idea. Yeah, so if there are no questions, then I'll stop from my end.
Thank you so much, Mr. Aryal, for joining us and dedicating your time and effort to share your knowledge and experiences with us. It was really helpful, and we learned a lot from your session. Thank you so much. So
yes, thanks for the opportunity, and then yeah, I hope it was helpful, and then yeah, everyone will do research with some good impact, and then yeah, all the best for everyone for the research.
and once again, I would like to thank Mr. Saugat Aryal for joining us, and all the students in the software engineering students community for organizing. So the students who are present here, to everyone. Finally, we have come to the end of this event. And dear students, I hope all of you were clear on what was discussed. And I hope this session was found interesting. I wish all of you best of luck. Stay safe and healthy. Thank you.